Specifically, I will present the carbon dioxide conversion to fuel. Again, the CO2 emission and its adversities. We were talking about the emissions of carbon dioxide, that how rapidly the emission has been increased. If we look from 1940 so till 2024, the latest data shows that the CO2 emission is up to 37.41 billion metric ton per year, with a huge exponential increment in the CO2 emission because of industrialization and other transportation sources. And nowadays, the race of technology for which the fossil fuel consumption is so big, so that results in the so much CO2 emission to the environment. So if we only talk about the very big two adversities like the sea level variation because of this CO2 emission, so that is currently it is 98 millimeter per year. And then if we see the countries which are most vulnerable to the river flood, so the 9 out of 10 countries is belonging from the South Asia region. Like top one, we can see Vietnam, Egypt, Bangladesh, including Pakistan, with a 9.5 risk index score out of 10, which is too much high. And we can observe every year Pakistan and our other South Asia countries are suffering from the flooding effect because of the climate changes and because of this CO2. Even in Bangladesh 2022 and Pakistan, it has been observed that around 7.2 million people were affected because of the flood. So due to the climate change, we are not only suffering from the fatal losses, human losses and other infrastructure losses, but also economic losses as well. Like we can see the earthquake is the top of the adversities, and then with the $99 billion, including the flooding, which is $85 billion. So this shows that how severe this CO2 emission and the climate change and effect is currently, and as well as the near future as well. So that's why people are nowadays working to how CO2 can be utilized and how to produce the neutral net carbon environment. So currently, there are two major technologies for the CO2 conversion, apart from the CCO, carbon capture and utilization. So the one is electrochemical conversion, in which we provide the potential electricity through the renewable energies to convert CO2 into other fuels. And the one is thermochemical, in which we provide the heat like 300, 350 range, to break down the CO2 and then provide the hydrogen for protonation to convert into useful product like CO, ethane, ethylene, methanol, ethanol, etc. So if we give a sharp comparison between these two methods, so we come up with that electrochemical is much better regarding the uses of electricity, renewable electricity, and ambient condition operation. Because in thermo one, we are using high temperature, which is also used by some fossil fuel or which generate heats, which is not good for climate change. And also the hydrogen we provide in thermochemical, but in electrochemical, that is quite similar, the water and the CO2, and very accessible feedstock for the electrochemical conversion. Although energy efficiency is not that much good, because of which electrochemical cannot be industrially applied so far. But the researcher are in the efforts to uh, make it industrialize as much as possible, as soon as possible. So that's why I will focus on electrochemical conversion. So for this, we had some paper, review paper, just with the help of our team combination team members, regarding the CO2 product. Basically that review paper is CO2 plus product like ethylene, ethanol, ethane, on copper, CO2 electroreduction. Because copper is one of the most used catalyst for electroreduction of CO2 because of its versatile nature. It can produce up to 16 products, uh, and no other catalyst can produce such a versatile products through electrochemical reduction of CO2. Because every catalyst has some specific product like silver, iridium, palladium can be used for CO generation, and then tin can be used for format generation. But copper has ability to produce oxygenate, alcohol, and other hydrocarbons like methane, ethane, ethanol. So it totally depends on the parameter which you are applying with the copper catalyst. So in this paper review, we just summarize few things regarding this, regarding the copper catalyst, that how we can improve the C2 plus products through the copper catalyst. Like that is the abstract in which we can see that carbon getting from different sources, industries, transport like cement, coal combustion, and then all of this CO2 sources, getting from them CO2, we utilize the carbon dioxide reduced reaction technologies like H-cell reactor, which is very traditional reactor for CO2 conversion, and then membrane electrode assembly cell, which is one of the newest methodology and reactor setup. Then photoelectrocatalysis. Using these cells, we can convert into various fuels like ethanol, ethylene, and CO. CO can be used further with the